It's springtime in Canada. The snow has started to melt, the water started to run, and I have started dreaming of summer. I can almost feel the warmth of the sun on my face and the cool water of the lake as I dip in. But there's a snag when I get there. There's a sign up saying that I can't go in the water. If this has ever happened to you, you've already met your local cyanobacteria. You might also have encountered them in the news under their aliases, blue-green algae or algal blooms. They're always there in the water, but they're not always causing trouble. Usually when they start to become troublemakers is when the temperature is just right, when it's nice and warm, and when there's lots of nutrients like nitrogen and phosphorus. And then they start to grow and grow and grow. And once they start their takeover, the water starts to become green, a little bit smelly, and often toxic. And this causes problems because not only can you not enter or drink the water, but your drinking water treatment plant can also be unable to handle the increased levels of bacteria and the toxins produced. And you can have entire cities that have to go out and buy bottled water because their tap water is going to make them very sick. So why do cyanobacteria produce these toxins anyways? Is it just something that they produce regularly, sometimes as a part of some other process, or is it because they are trying to kill off the competition? We really don't know. One possibility is that nitrogen is a factor because the toxin molecules are very rich in nitrogen. And nitrogen can come packaged in different forms, like urea, ammonium, or nitrate. And what I want to know is whether the form that nitrogen is packaged in has an impact on the kind and amount of toxin that is produced by cyanobacteria. How I'm looking into this with my research is first of all with a small scale experiment where I put containers in Buffalo Pound Lake in Saskatchewan, and each container has a different form of nitrogen. And then I will look at the effect on the toxins. I also want to know whether this is true not just for Buffalo Pound, but for other lakes as well. So I'll be using something called a systematic review to look at previously published literature and see what the impact of these nitrogen forms is on the toxins. So hopefully we can better understand the conditions that cause cyanobacteria to produce toxins. So even if we see more and more of them as temperatures continue to increase, that hopefully they cause a little less trouble along the way. Thank you.